There in the yellow shirt.
Bob Willingham, resident.
Okay. And ma'am?
Allison Wonderland.
And are you a resident?
Yes.
Thank
My
you.
husband and I just moved.
Great. All right. So, gentlemen, getting back to you on the phone. You've introduced yourself. We know you work for the National Sanitation Foundation. So, and one thing that I'd like to point out is any products added to drinking water in Colorado have to be approved by the Colorado Department of Public Health and Environment. The Public Health and Environment Division will only approve products that have been certified by the NSF. So, gentlemen, what we're talking about today is a product called Sequest, which the district has used as a corrosion control in its water since at least 2008, and some of the CDPHE records it appears that it may have been used well before that time. But can you tell us, with regard to this particular product, I think there are many questions as to the toxicology of this product. You know, is it toxic? What's the process for approval? And what assurance is there that this product is perfectly safe for consumption and use in public water systems?
Hi again, this is Kevin at NSF International, and I'll address those questions. Basically, when a product comes in for certification, what we do is a manufacturer will have a recommended dose rate that they would like to try to have the product certified to. And so what we do is evaluate that product to see if that product is actually safe at that dose rate. In addition, we also want to look at any potential contaminants that might be within that particular product. So for a phosphate, now again, Sequest is a blended phosphate product. Now, it is a proprietary blend, so unfortunately we can't disclose the exact phosphates that are in that product, but I wanted to describe generally the toxicity of phosphates and polyphosphates as we would evaluate them at NSF International. So, typically under our standard, NSF Standard 60, we limit phosphate products to a dose rate of a contributing dose rate of 10 milligrams of phosphate, so that's PO4. Now, that is not actually a health number. We've limited those products based on what's typically used for corrosion control, which is usually between 0.5 milligrams and 5 milligrams. But what we really are concerned with that dose rate is the environmental effects, because we need to be concerned about the amount of phosphate that's being exited in the wastewater because of eutrophication of water sources after wastewater treatment. And so we need to limit that because phosphorus can provide a nutrient for growth of microbacteria in water sources that wastewater is discharged into, and there's state limitations for amount of phosphorus being discharged.
Right. Yeah, I think we need to kind of break that down a little bit. I'm not sure if everyone kind of understood what he just said.
Well, let me follow the logic here a little bit. One of the points that you made is about your approved limit. The product we use is the liquid form of Sequest. That's approved up to, what, do you guys have the spec sheet in front of you?
It's approved up to 28 milligrams per liter in the liquid form. Now that, of course, is a diluted form from their solid version. And that maximum use level is, again, based on a maximum contribution of 10 milligrams of phosphate per liter. Now, it's my understanding that you're using that particular product at only 0.5 milligrams per liter. Is that correct?
That's correct.
So here you're using that chemical at far below its typical use level. And so you're well below even 10 milligrams of phosphate. But again, that 10 milligrams of phosphate, again, is not a health number. I'll get into the health number of phosphates in a little bit. But I want to also describe what we really are concerned about more in testing these particular styles of products is contaminants that come with these products. We're concerned really about regulated metals, and those metal lists could include, antimony, arsenic, barium, beryllium, cadmium, chromium, copper, lead, mercury, selenium, and thallium.
Right.
Those are metals that could be potential contaminants in that particular product because, again, phosphate is really derived from a mined source before it's refined into its current product forms. And so we test the products for those metals, and they have to meet our specs, which are single product allowable levels, which are based upon the EPA's MCLs for drinking water quality. And that's basically a tenfold amount less than that. And so if you're even dosing it in 0.5, which is well below its maximum use level, again, by being certified NSF, you're ensuring that the levels of those metal contaminants are far, far below any type of safe level.
Right, so just to clarify, you've certified it as safe, and if there were to be any metals like that, they would be in such a minute amount as to be, what you said, tenfold less than what would be considered a health hazard.
Even more. I mean, so yeah, the levels that are at that point are basically toxicologically almost insignificant at those levels.
Okay.
So, and we also test the products for fluoride content as well as for radiological activity because, again, it's a mined product, so we do look for gross alpha and gross beta numbers. So those are the types of contaminant tests we run on the particular product, and they have to meet our pass-fail criteria when dosed at its maximum use rate. And so when we evaluate it, we test those levels assuming that the product is actually being dosed in at 28 milligrams per liter. Now, so even if you're dosing that product in at 28 milligrams per liter, by certifying it NSF, we're stating that you're not going to be exceeding any of those criteria for metals, radionuclides, or fluoride content in that particular phosphate product. Now, for phosphates itself, again, I can't disclose the exact composition of this particular product, but what we have for a lot of our phosphate products, we have ortho phosphates, polyphosphates, tripolyphosphates. You'll see a lot of those on our NSF listings. And those are typically used in corrosion and scale control. And again, we limit that dose to 10 milligrams of phosphate. But phosphate itself, or even these tripolyphosphates or polyphosphates, what happens is, and when they hydrolyze, they basically become orthophosphate. And phosphate itself is an essential nutrient for the human body. So basically, if you look at any of the dietary recommendations, such as the dietary recommendations set forth by the National Institute of Medicine or the Council for Responsible Nutrition, let's stay with the National Institute of Medicine. That one basically set a daily reference intake allowance of 700 milligrams of phosphorus. And if we're even just talking about dosing this particular product at 0.5 milligrams, that is far below what's even recommended for the body to intake as an essential nutrient. I mean, phosphate is used throughout the body. Phosphorus is a primary component of human bones. One of the most vital chemicals in the body is ATP, it's adenosine triphosphate. It produces energy for cells, and that's actually that's a polyphosphate that's within your cells to produce energy. I mean, phosphate itself is vital for the human body. Now, again, as any toxicologist will tell you, the dose will make the poison. I believe that's from Paracelsus. And
I think you're right.
And so, too much phosphate can have some toxicity. And those national organizations have looked at that and have set upper limits. I believe the National Institute of Medicine has set an upper limit of 4 grams of phosphorus as a safety limit, and I believe their endpoint was that once you start getting above that amount, you might get calcifications occurring in the kidney of calcium phosphate. But again, that's a huge. If we're looking at a dose of 0.5 milligrams, assuming that our dose is 100% phosphate, which is just not, but let's say just for argument's sake that we're dosing this particular chemical into the drinking water at 0.5 milligrams. That is, we're talking 1,000-fold away from even the recommended daily amount, and then even further away from what an upper safety limit would be set by many groups such as like the National Institute of Medicine or the Council for Responsible Nutrition. European agencies have also looked at this and set similar levels. So again, the toxicity of the phosphate chemicals themselves is really non-consequential in these particular products, and when NSF really evaluates these products, our concern is primarily with the contaminants that come with these products.
Okay. And of course, your reason for your testing is to verify that those contaminants are so minute as to not pose a health problem, if in fact they even exist.
Even if they're present, correct.
Right.
And those pass-fail limits, this is Blake Stark, those are set, the EPA sets a maximum contaminant level for the drinking water. The pass-fail limits on those that Standard 60 uses are 10% of that. So if you were to dose the product at its maximum use level, it would not be able to contribute more than 10% of the MCL for each of those respective contaminants. That's correct.
Okay. Hey, guys, I just want to check real quick and see if anybody
Oh, Lord.
is there anybody on the phone from AquaSmart?
Yeah, I'm here. It's Michael Edelstein, National Sales Manager.
Hi, Michael. Hey, one of the things that I wanted to ask you about is, and we're on the phone with the National Sanitation Foundation. I've got Kevin Cox and Blake Stark. And one of the points that they made is that they test products for safety and established limits, and your product is tested and they've established that it is safe. And their limit for the particular product we use is 28 milligrams per liter. That's the liquid form of Sequest. Now, they did mention that your product is proprietary, and that's what I wanted to talk to you about a little bit. That seems to come with a little bit of, mystery, if you will, and we'd like to know, with regard to proprietary, what in fact, what's in the product and why is it considered proprietary? Can you expand upon that a little bit for us?
Well, the reasons why, first off, can you hear me okay?
Yeah, we can hear you.
All right, wait, you know what? Let me get off the speaker here. The reason why it's proprietary is because we are the only product that can do things that no other product can do. So we had an option of either patenting it or else just keeping it secret, like a secret formula, like Coca-Cola is secret formula. And the reason for secret formula is that we opted for that is because it took about 18 years of research to develop this product safely so it would be able to do things no other product can do in the market. Now, we are actually the only product on the market where we claim and document and demonstrate and reference that when you use our product, you're using less chlorine in the system. And so we actually are designed to help reduce other chemicals such as pH adjustment chemicals like caustic soda or soda ash or lime, that you can actually reduce those because we work effectively in ranges, pH ranges and temperature ranges no other product will work in.
Okay.
So that being the case, because we are a unique technology and the only third generation technology, that is why we keep our formula secret. Now, what I can tell you is that in the groups, the phosphate groups, there are 18 manufactured known phosphates. Our phosphates are developed from the sodium phosphates. Okay. There are 10 sodium phosphates. 2 are not food grade. 8 are. And we only use the food grade phosphates from the selection of the 8. I can't tell you how many. I can't tell you in what quantities or anything like that. And so, that's the situation as far as the product goes. But I can tell you it is in the sodium-based phosphate, and phosphates, as our NSF representatives told you, that these are totally safe and 100% food grade. We don't add any fillers to our product, which is important because some of our competitors do add fillers, and we don't know what those fillers are. We are 100% food grade phosphate product from the sodium category.
So you said it's all food grade phosphates, and there are 8 different, and that's all you use. They're all sodium phosphates. So I'm a layperson in this matter, and it sounds to me like in effect what you have is 8 different pieces, or
Well, that's our maximum. I'm not telling you how many pieces there are.
I got you.
I'm just telling you that
I'm saying different.
That are food grade. It's within that 8.
That's what now I understand. Of those 8, you put them together in some quantity and in some way that you don't want to share because you're a private business and you have competitors. I mean, is that fair?
Yeah, I mean that's why most, I can't say all, but most of our competitors also have proprietary products also. Unless you're buying something very straight and like a sodium hexametaphosphate, well, that's different. But when you're doing a blended polyorthophosphate product, it's going to be a blend that every competitor has their own little, secret formula.